Welcome back. We're going to be finding average rate of change in this quick little review. Average rate of change of y with respect to x on a certain interval. So here is our function, x cubed plus 2. And the interval is 2 to 3. We're going to find the average rate of change. Well, average rate of change you can remember, should remember. There's a couple ways you can see it. I used to teach it many years ago as f of b minus f of a over b minus a. That's just using function notation. You may have learned it as y2 minus y1 over x2 minus x1. Whichever formula you use, you're going to get the same result. Now, what does this f of b minus f of a or y2 minus y1 mean? That means we are going to find the y values for each of the corresponding x values. So we have 2 and 3. So how are we going to find y? We're going to plug in 3, substitute in 3 into x cubed plus 2. So 3 cubed is 3 times 3 is 9. 3 nines are 27 plus 2 is 29. So that's 29. I'm going to do a different color. Let's do, I don't want to do it in that color. What color I want to do? Bright green? No, we'll do it in, we'll do it in red. I'm wasting too much time here. 9. 29 minus. So that's my y sub 2. Y sub 1 is plugging 2 in there. 2 times 2 is 4. 2 4s are 8. Plus 2 is 10. That's my y1. Over, very simply, 3 minus 2. That's my x2. This would be my x1. I'm sorry. This would be my x1 and my x2. This is an interval. So here we have it, and this becomes 19 over 1. That is my average rate of change of x cubed plus 2 over the interval 2 to 3. So, moving on with that, since average rate of change has something to do with it, we're going to talk about a theorem in calculus that deals with that average rate of change, and it's the mean value theorem. So let's talk about the mean value theorem. The mean value theorem. The mean value theorem states that we have a continuous differentiable function on some interval. Then there's some c value such that the derivative at that c value is equal to the average rate of change over that interval. Other ways you may have seen it is that the slope of the tangent line at this point c, or at this location c, is equal to the slope of the secant line over that interval. You had a problem on one of your recent problem sets saying, given f of x equals 9 minus the quantity 14 divided by x, given that function, find all c values, that's this guy, find all c values on the interval 2 to 7 such that the mean value theorem applied. So f of 7 minus f of 2 all over 7 minus 2. So what do we have to do? We have to find the derivative of this function. We have to find the average rate of change of that function over the interval 2 to 7. So let's do that. Let's find the derivative first. So the derivative at x, that's 0. This, remember, becomes 14x to the negative 1. So taking the derivative of that would result in 14x to the negative 2. And over here we have, that's the derivative, and we're going to set that equal to the average rate of change. So f of 7 is this guy, so 14 divided by 7 is 2, 9 minus 7 is 2. Oops, did I do that right? Let me see, 7, 2, yeah, it ends up 7. This is 7, 14 divided by 7 is 2, 9 minus 2 is 7. Plug in 2 for f of 2, that's 7, 9 minus 7 is 2, over 7 minus 2 equals 1. So moving up here a little bit, we have 14 over x squared equals 1. Multiply both sides by x squared, I get 14 equals x squared. Take the square root of both sides to get x is equal to the square root of 14. A lot of people want to do plus or minus 14, but remember our interval, 2 to 7. So it's only going to be the positive 14. So here is the mean value theorem, and this is true, where the derivative at an x value, we're calling it c, is equal to the average rate of change. So however you want to talk about it, here's a little quick graph. You have a graph, some sort of function, and we draw a line. We're going to say that there's the average rate of change would be the slope of that line, that there's some c value right here. That means that this slope, the slope of this line, is equal to the slope of this line. That's the mean value theorem. Well, I hope you enjoyed this review, this quick review of average rate of change and also the mean value theorem. Johnstone, out.